I've got a special project for you today. I've been working on this Christmas Eve gift box for my son. This is my first attempt at 1, making a box on my CNC, and 2, doing a wooden inlay on my CNC. I'll take you through the process and share my mistakes I made along the way. I started this project by milling down some 1-inch thick rough sawn walnut. Using my miter saw, I cut the pieces to a rough length. The overall dimensions of the box are 18 inches long by 8 inches wide by 6 inches deep. I cut these pieces a little longer than I needed to give myself some wiggle room for snipe or other adjustments I needed to make along the way. Then, after milling, I would trim them to their final length. I wanted the box to be something substantial in size, so we could fit pajamas, a book, a movie, or whatever else we wanted to gift on Christmas Eve. This played a major part in my design thought process. I wanted the individual pieces of the box to be made out of one solid piece of walnut. That means I would need at least 2 pieces that were 8 inches wide for the top and bottom. For the sides, pieces of wood would need to be at least 6 inches wide. I decided that all the pieces of the box would be a 1/2 inch thick. Next, I started thinking about the CNC milling process. I immediately thought about the outer contour cuts. The actual toolpath that cuts the shapes out was going to take way too long, and that since I was already milling the pieces down using the table saw and the miter saw, why not just cut them to the size they needed to be using those tools? It would be so much faster. Then I would just use the CNC for the inlay portion and to cut the rabbet box joints and the rabbet for the sliding lid. I've done something similar to this before, where I'll cut down pieces of wood to the exact size that I need and stack them up on my CNC bed so I can carve multiples of something out of individual pieces of wood at a time. So, with all those thoughts in mind, that's what I decided to do. Now I realize some of you might be asking, why not just use the table saw to cut the rabbets too? That is a great way to do it, but for my case, I didn't have a flat tooth saw blade in my table saw, and once I designed it in CAD, it would be more repeatable. That if I want to make another box in the future, I could do that really easily. After all, creating 1/4 inch rabbets on the CNC should be super easy. The tools I'm using are 1/4 inch in width, so literally just one pass width-wise, and it'll give me consistent rabbets every single time without having to measure, and it is super repeatable. So before even starting this project, I did consider other CNC joinery methods, including box joints, including hollowing out using a bowl and tray bit. But after comparing all those joinery methods together, rabbets seemed to be the best for this project. Once I had them designed in my CAD software, I wanted to do a test, hopefully catching my mistakes before I made them on the walnut. I set up the toolpaths, and I used a 1/4 inch downcut bit for the box joints and an 1/8 inch downcut bit for the lid slide groove. The lid slide grooves are 1/4 inches in width, but because it is a pocketing toolpath, it wouldn't allow me to use a 1/4 inch tool. So that's why I'm using this 1/8 inch tool. Looking back, this is where I made a major error in this project. Let me explain. I had some 1/2 inch MDF on hand, so that's what I decided I was going to use for the test. It was in a large panel, and instead of cutting out the individual pieces of walnut, like I had done for the walnut, I decided just to put the whole panel on the CNC bed and cut them out of the whole panel rather than the individual pieces. Would have saved me a ton of time. And it all makes sense here in a second. All right, with that aside, I did learn some things from this test. I learned that the box joints fit well, and it confirmed that all my dimensions were correct except the lid. The lid ended up being too wide, so I had to make those adjustments. I also learned that one of the ends doesn't need a groove for the lid. This is where the lid will slide in, and it actually needed to be shorter to be able to accept the lid. After making these adjustments, I was ready to lay out my individual pieces of walnut on the CNC bed. Remember that each one of these pieces represents the same piece in the CAD software. They're laid out the exact same way. I'll zero to the lower left corner so everything will be referenced off that point. I hit start and hope and prayed for the best. As you can see, some of the things are slightly off. This revealed that some of my tools are not as accurate as I thought they were. If I'm even a 1/16 of an inch off, that means the box joint is going to be a 1/16 of an inch off. The CNC is goes exactly where you tell it to go, and my layout just wasn't as accurate as it needed to be. So after some frustration and thought, I decided that it wasn't worth chasing this thought process anymore. Even though I knew it was going to take way longer, I went back to what I knew worked. Making a 30 by 30 inch by ½ inch panel and using the CNC to cut out the outside contour paths, the shapes of the pieces, and use tabs to hold them in place. So I added the outside contour toolpath and adjusted the layout to fit the panel. Adding this toolpath added about 25 minutes to the total milling time on the CNC. 25 minutes doesn't include cleaning up the tabs to hold them in place. At the end of the day, honestly, I wasted way more than 25 minutes, and it probably wasn't worth it. Okay, so moving on to the inlay. Like I said before, this was my first wood inlay I've ever done on a CNC. I'm using an exotic wood called paddock or padauk, as some say, for this inlay. This is a really cool orange color wood, and it pairs extremely well with walnut. I knew the basics on how to do the inlay, but I did some research before I jumped in. Basically, you make a female side and a male side. The female side is very straightforward. I did this with an advanced V-carve toolpath, setting the maximum depth to 0.2 inches. I used a 1/4 inch downcut bit to clear the bulk of the material, and then used a 45-degree V-bit for the details. The male side is the tricky part here. This is the main resource I used to wrap my brain around this concept. I'll also link some additional resources in the description below if you want to check out more on how to do these V-carves. But basically, if you were to do the same exact toolpath for the male side and the female side, the pieces would not fit together. In order to get them to fit, you need to set the starting depth to 0.1 inches and keep the max depth at 0.2 inches. This does a couple things. It creates a bottom gap in your inlay that will allow for glue to settle in, and it makes the pieces slide and lock together. With these settings, I got it on my first try. Once I knew the two pieces fit together, I assembled them together using a lot of clamps and a lot of glue. Next, it was time to assemble the box. Some strap clamps would have been useful here, but I just used a bunch of single clamps, being sure to get pressure where I needed to. I was happy with how most of the joints fit together, but there were a couple that were carved a little too deep. This revealed a couple things. To increase my accuracy on these precise projects, I need to flatten my spoil board first. Although I milled my rough walnut completely flat at the beginning, I didn't flatten it after the glue up. The only way I could have done this is by using a surfacing bit on my CNC bed. Basically, if any of my stock was higher or lower on the CNC bed, it changed the 1/4 inch rabbet depth, which in turn changed the fit of the joint. But overall, assembly went fairly well. While the box was drying, I turned my attention back to the lid and inlay. I took it over to the bandsaw and removed the excess padauk. Then I took it over to my drum sander and sanded the panel flat. I know a drum sander is a luxury, and you could use a random orbital sander here too. It would just take a little longer. Overall, I was happy with my first inlay. I got the box out of the clamps and tested the fit of the lid. It fits, but I'm not 100% happy with it. It's a little loose, but will suffice for this project. I then cleaned up and filled any cracks on the box and did a final sanding before applying finish. As I said at the beginning of the video, this was all new to me, and I learned a ton. All right, so let's recap what I would do differently. First, I'd make 3 small panels to cut my pieces out of. Gluing the large 30 by 30 panel up was tricky to get everything flat with enough clamp pressure. Second, I'd pay attention to the grain direction on my panels. I'd make sure the grain is running the length of the panels and not perpendicular to it like it is now. This would reduce the number of individual glue joints in the box, making it stronger, and it would be easier to sand. Third, I need to redesign the end of the box where the lid slides in. I'm not sure what I would do here, but I don't like the way these exposed slots look. Number 4, and most importantly, before I started, I would surface my wasteboard to make sure it is dead flat. I'd also surface my walnut stock to make it perfectly level with the wasteboard. The first time you do something, there is always going to be mistakes. That's just a given. But if you're able to push through them and learn from them, it'll make your next project even better. So I hope this encouraged you to try new things and not to be afraid to make mistakes. Overall, I am happy with how this project turned out, and it will work for this year. I will be making another one of these because this is something I want to last a really long time, and I kind of want to perfect. That is, it'll be here long after I'm gone. So if you're not subscribed, make sure to hit that subscribe button so you do not miss when that video comes out. I've got a lot of other build videos that I'll put in a playlist right here for you to check out. Thank you so much for watching, and I'll see you in the next video.